Hello everyone, good evening and welcome to my channel Aptitude Club. Today we are here with an interesting question on quadratic polynomials and its roots. Now it's a very beautiful question and the purpose of taking this question is to share your thought process, how algebraic identities are integrated into this question and how we can use those relations to arrive at the answer of this particular question. This question can be modified in a lot of ways, so I have taken just one of the many ways to explain, but it will give you a thought process to keep going and then implement and maybe improvise in some other questions on similar lines. So as always, I'll request all of you to pause at this moment, try the question yourself first and then look at the explanation. Alright, let's begin. So here it is saying that this is a quadratic polynomial x square minus x plus 1 equal to 0 and alpha and beta are the roots of this quadratic equation. Now whenever we have a quadratic polynomial, in a quadratic polynomial the number of roots, if I am taking a quadratic polynomial or quadratic equation, the degree is 2. Degree means the highest power of the variables present in the equation, and degree will give you the number of roots. This implies the number of roots is also 2. So here it is a quadratic polynomial, thus it has two roots alpha and beta. So in general, if a quadratic polynomial p of x is ax square plus bx plus c, I'm just explaining this to give you a context for those of you who haven't read quadratic polynomials. If it is in this form and alpha and beta are the roots of the polynomial, this implies I can say p of alpha is equal to p of beta is equal to 0. That is the whole definition of a root. What do you mean by a root? That means when you take that value and put it in the polynomial, you get it as 0. So for an example, if I take alpha and put it in the polynomial, I'll get 0, which means alpha square minus alpha plus 1 is equal to 0. In place of x, if I'm putting alpha, it will give me 0. Similarly, I can also write beta square minus beta plus 1 is equal to 0. That is the meaning of roots. Okay. And then we have relation of roots, that is alpha plus beta. Sum of roots, it is minus b by a. B is the coefficient of x and a is the coefficient of x square, and alpha into beta, it is c by a. So we will use this context to arrive at our answer. Okay, roots are the values of x which we put in the polynomial to get 0, and then sum of roots is minus b by a, product of roots is c by a. X square minus x minus 1, and naturally we will be tempted to find the roots, and we know the relation of roots यहाँ पे minus b by a and plus c by a. We also know how to find the roots using that formula minus b plus or minus b square minus 4ac by 2a. But if you get that root, it will be irrational number in this case, and once you get those irrational number, then finding to the power 5003 to the power 3005, the moment you see such numbers, definitely this is something to do with identities, because we cannot find the 5003th power of any number. It's not possible. Okay, and if you look at the answers also, these are simple numbers, so somehow this expression with so much higher power is going to be simplified. That's our clue to get started. Now think about it in this way. We have an identity, this a cube plus b cube. I can write it in this way: a plus b whole into a square minus ab plus b square. Okay, this is the identity that we are going to use. So in this identity, if I am writing it in this way, x cube plus 1 cube, so it is like a cube plus b cube, so I can expand it as x plus 1 whole into x square minus x into 1 a into b plus 1 square. So x cube plus 1 is x plus 1 into this thing. Now once you have got this, now think about this. This is the polynomial and we have these two relations. Let me write it here. P of x is x square minus x plus 1, and because alpha and beta are the roots, so I can write alpha square minus alpha plus 1 is equal to 0 and beta square minus beta plus 1 is equal to 0. So yeah, here substituting x as alpha, I can get alpha cube plus 1 is alpha plus 1 whole into alpha square minus alpha plus 1. Now this alpha square minus alpha plus 1 is equal to 0 because alpha is a root. So this implies alpha cube plus 1 is equal to 0 because this entire thing will become 0 now. Or this gives me alpha cube is equal to minus 1. Now here note that from this, do not write alpha cube is minus 1, so alpha is equal to minus 1. Don't write this because this is incorrect. Although you can argue that okay, minus 1 cube is also minus 1, so why not take alpha as minus 1? But if you take alpha as minus 1 and put it here, minus 1 square minus 1 plus 1 is not 0. So alpha cannot be minus 1. So alpha cube is minus 1, we'll keep it that way. If we use the same logic again for beta, I can write it in this way, that beta cube plus 1 is like beta plus 1 whole into beta square plus beta square minus beta plus 1. Again this thing is 0. So this gives us beta cube plus 1 is equal to 0. And again beta cube is minus 1. But beta is not equal to minus 1. We get this. Similar logic. So alpha cube is minus 1 and beta cube is minus 1. So we got this. Now we have to find alpha to the power 5003 and beta to the power 3005. Before that, we'll just use another small thing, that if I'm writing alpha plus beta whole square, so it is like alpha square plus beta square plus twice of alpha beta. Now for this particular quadratic polynomial that we have, p of x is x square minus x plus 1. So here a is equal to 1, b is equal to minus 1 and c is equal to 1. So sum of roots alpha plus beta is 1 and product of roots alpha into beta is also 1. So if you put these two values here, so I get alpha plus beta is 1. So 1 whole square is alpha square plus beta square plus 2 alpha beta, so 2 into 1. So basically I get alpha square plus beta square, it is minus 1. Now one thing that you can argue here, how is alpha square plus beta square minus 1? You can argue that here, because if they are roots, how is their square? Because square of anything should be a positive number. So alpha square plus beta square, how can it be minus 1? Now think about this. If I am taking the roots here, let me calculate the discriminant. Discriminant is b square minus 4ac, so minus 1 square minus 4 into 1 into 1. So I get 1 minus 4, I get minus 3, which indicates imaginary roots. So we are not dealing here with real numbers, we are dealing with imaginary numbers. Okay, so that is why we are getting such kind of cases. So that is why I said you, when alpha cube is minus 1, don't take alpha as minus 1 because that's a real number, but alpha and beta are imaginary numbers. So you keep it in this way and we'll use this relation, alpha square plus beta square is minus 1. So in the end, we'll have to calculate alpha to the power 5003 and beta to the power 3005. So alpha to the power 5003 plus beta to the power 3005. So I can do it in this way, alpha cube, I know the value. So 3 into, if you do 3 1s are 3, then 20, 3 6, then again 20, 3 6, 23 into alpha square plus beta cube, again 3 1001 into beta square. Now alpha cube and beta cube we know the values, which is minus 1 both cases. So minus 1 to the power 1667 into alpha square plus beta square into minus 1 to the power 1001. So I can take minus 1 alpha square plus minus 1 into beta square. So minus 1 taken common, I'll have alpha square plus beta square, and alpha square plus beta square we got it as again minus 1. So it is minus 1 into minus 1. My overall answer is plus 1. Beautiful question. And how beautifully this identity a cube plus b cube, a plus b, a square minus ab plus b square is integrated. So first in place of x I put alpha, I get the value of alpha cube. Similarly I'll get the value of beta cube, and then alpha plus beta we got it as sum of roots, alpha into beta as product of roots. From there you get the value of alpha square plus beta square, and then you just do this, you will get alpha to the power 5003 plus beta to the power 3005, and as such any power given now you can calculate. Okay, so the clue was the moment you see higher powers, you should understand that we will not calculate something to the power 5003 basically. It has to do something with identities. So the answer here is minus 1. Sorry, minus 1 into minus 1, the answer is plus 1. So option 1. Hope all of you understood this question. Very important and very good question on quadratic polynomials, I must say. And I hope all of you enjoyed the explanation of this. Try and solve more such questions on quadratic polynomials to strengthen your understanding of concepts. I have done a lot of questions on this QA Booster playlist, and I'll pin it in the I section. Do check it out. If you are new to my channel, do check out the previous videos that I've done. You'll definitely find them useful on your CAT preparation journey. And I hope you like the explanation of this video. And if you watched it this far, do subscribe to my Aptitude Club channel and let me know in the comment section what you felt about the question. We'll meet again very soon on yet another video. Till then, keep solving, keep studying, and thanks for watching the video. Bye bye.